we started a little ahead of time, just checking the connection and all that. So maybe we will be waiting for another 5 minutes for others to join. And I hope you all are doing good in this pandemic situation. Today is the starting point of 3-day workshop on artificial intelligence. After this workshop, you will probably get uh, a considerable amount of idea about the basics of artificial intelligence and data science. So uh, let me just okay, let's just wait for few minutes. Okay, let me see how many of you have joined. It's yeah, if there is any issue regarding the audio and video, you can tell right now so that we can fix it before starting the session. So in the chat group, you can share your thoughts, if any, regarding connectivity issues. Till then, others will join. Okay. Azharuddin Sheikh, increase your pitch. I'm loud enough, I guess. Is there anyone else who is having problem with hearing? Maybe if you can increase your volume a bit. Let me also just for let me just check my volume. This is a speaker. Won't do any. My mic is working, I guess. Hello everyone. Hello, Kashif. So we will maybe we will wait for another 2 minutes. It's 6:31. So another 2 minutes, then we will start. We'll dig up some artificial intelligence. Okay. Let me just do one thing. Let me just open the okay, maybe I can. Uh, 13. Okay. If I am not wrong, there are more people in the group, I guess. Says around 22 participants, including the admin. So if apart from 3, it may be 19. So good enough. Okay. If more than 50% are here already, we can start. So let's talk about artificial intelligence, right? So let's just jump to our first definition. So what is artificial intelligence? before starting the subject itself, let me tell you, John McCarthy, he is considered to be one of the uh, founder of artificial intelligence. He actually coined the term. Okay, so the word we use today, artificial intelligence, John McCarthy coined it, and he described it as a science and technology of producing intelligent machine. Okay, nevertheless, if we split the phrase artificial intelligence, the word artificial here means actually learning from experts, right? So artificial means it is not naturally, the machine doesn't learn naturally. We need to provide some amount of training, some amount of data, some amount of reference to the machine in order to make them learn. Okay, so that's why it is artificial. Unlike humans and other living beings, we learn naturally. Okay, there is no explicit training from anyone we get to learn things. Of course, in education we do, but in general in life we don't need such thing. So that is why it is natural, but in case of machine it is artificial because of that. And intelligence is something, the collection of task specific skills. Okay, and in general word it is a general learning ability. How good is a machine learning? Okay, that is the intelligence of the machine. So we give certain amount of process to the machine and see how good the machine is responding given that certain amount of training. So that can be used, given by experts, that can be given by data. Now there are two distinct criteria I have written here. Learning from experts, learning from data, is because when we use explicit hard coded rules, hard coding, okay, hard coding means there are set of instructions, okay, uh, and the computer or the machine performs those instructions line by line, and according to those instructions or according to the set of rules, the machine performs certain tasks. Okay, if the task falls out of that rule, the machine cannot do the task. Okay, so this is hard coded uh, task. Okay, so apart from those instructions, the machine cannot do anything. In case of uh, data, however, when we give machine a data, then the machine actually learns from the data, not explicitly from the instruction, and on that learning it can perform certain operation on an unknown data. So a data which is known and a data which is unknown. Okay, so the transition or the task performing capability on an unknown data given a known data is actually, in today's world, is called artificial intelligence or AI enabled machines. So whatever AI enabled machines we are talking in today's world, they are actually, they learn from data, not from experts or not from hard coded rules. Okay, the hard coded rules we used to do, or maybe some of you may have gone through some C or Java or some programming skills. There we coded like find the Fibonacci series or find the next prime number. So those are the hard coded rules. It cannot perform some other task or some other operation. If the data is something else, the code may fail. So that is a hard coded rules. So that is from experts. So you know how to find the prime number, you give the instruction and the machine performs that way. Okay, so this is the general idea of artificial intelligence. So let's move on and let's see. So the types of AI. Now there are three kind of AI that humans wants to achieve. Right now we are here. Weak or tight AI. Weak or tight AI means the system or the project, if you may say, or the product, whatever we are learning here, whatever we are doing, if we are building a system or if we are building a project or a product, that particular outcome deals with a specific task. Okay, so a specific task means, let's say if I want to build a voice assistance. Okay, voice assistance, so it will generally deal with audio data, right? So we give audio data as input, this is my input. Okay, and listening to the audio data, doing certain process, it will give some output. But this voice assistance software, which we call artificially intelligent, cannot perform any operation apart from audio data. If I give a video data, so let's say you are giving video data to Alexa, Alexa cannot understand what you are doing. It may crash, or it may say, I don't understand. Okay, so it is a very specific domain. It performs certain tasks depending on the specific data set. Okay, so that is why we call it a weak or tight AI. All, if not most of the AI systems in today's world, if not all, are tight or weak AI. Okay, then what is general and strong AI? General and strong AI is like almost like human mind. Okay, so there won't be any boundation. Any data it can process, any data it can take as input and give as output. So a general or overall design of a artificially intelligent model can take any data as input and give accordingly output, right? So you may say Sophia, that robot, is somewhat close ahead of tight AI and in the phase of general and strong AI. Still it has some lags in terms of, if you say, judge an emotion and give an response to it. Okay, it can judge your emotion by your facial expression, by your way of talking. That is also given as input somewhere. That's why he or she is doing. But generally it cannot understand the emotion. It can understand the pattern of your behavior. So okay, but somewhat it can mimic the human mind. So it is ahead, it is going ahead of weak and tight AI. And it is the goal of our AI human, what we are doing right now, is to achieve that general and go beyond the super AI. Super AI means beyond human mind, what human mind cannot capture or cannot understand or cannot calculate, beyond the computational ability of human mind. If someday there is a AI system or model that can let's say compute the last prime number, right, or that can take up some natural ingredients and build some medicine for a epidemic disease like corona right now. So those kind of AI system that is far beyond reality right now is called super AI, which is right now we are far away from the super AI. So we are here right now at the bottom end of this triangle. Okay, we try to move upwards. So these are the types of AI. Okay, so let's then jump to the next. So what is artificial intelligence and data science, or what are the connections, right? So artificial intelligence is consist of machine learning, deep learning. These two are one of the main pillar of artificial intelligence. And apart from that, there are other things like automation. Okay, then you may say robotics. Okay, and other several other components. Okay, so AI includes everything that can learn using data. Okay, so but the major part, the key part of AI is these two are machine learning and deep learning, which is also a part of machine learning. Okay, it is derived from machine learning and went beyond. Okay. And apart from these things, you also need some of the basics like linear algebra, statistics, and visualization. Okay, visualization means the graphical plots. How to plot data. Okay, so these are some tools from your engineering and maths background you need, and these are the tools from AI you need in order to create a data science project. Obviously there are other areas of data science you need to explore before you can do a full data science project, that is data mining. Okay, data acquisition. Okay, database management, DBMS, a little bit of DBMS. These are also other tools you need to know in order to perform a full life cycle of data science. So this is a let me say very simplified Venn diagram of the relation between artificial intelligence and data science. So these are the tools you need to learn on the first go. You need to have a hands on in those areas to in order to perform a data science project. Okay, okay, so given the idea of what data science is, what AI is, and what are the relations between those tools, let's jump into the actual conceptual idea of data science. Okay, so as it is written, data means information. Okay, here whenever we say data, we say information. Okay, whatever information we have. Information, of course, in many cases I have seen students that this is not the data I want, this is not required for me, or something like that. So let me tell you, any data is important, maybe not for the purpose of your application or for the purpose of the task you want to perform, but every data carries some amount of information one way or the other. Maybe it is noise for you, but useful for some other purposes. Okay, so every data you have or you may get in the process of data science project carries some information, it worth looking. So okay, and for that we have a thing called EDA. Okay, we will we will know what is EDA, that is exploratory data analysis. What is this, what are the things in exploratory data analysis in coming slides. Okay, but just to make you remember that information, even if you need or don't need it, it has some information. Every data has some information. Okay, even if empty cell, okay, if there is a row and column and there is an empty cell, this also information. Maybe you say what is the information it is carrying. An empty cell, this is there is no value, it is carrying information. Maybe you may need to find how many empty cells in a column or in a data, that may carry some information or some input about the process you want to build. Okay, so every data carries information in some way. Okay, so once we have the information, so from data we take the information, and from information we want to create a knowledge. Okay, so what the data is saying, if it is saying empty cell, what does that mean? If it is saying something else, what does that mean? So the meaning of the information we want to derive. Okay, so that is the process, and depending on the knowledge we have, we take decision. this is a essential part of data science, but not necessarily uh, should be there. Okay, it depends upon application to application. It varies from application to application whether you want to take decision or not. Many a time in your work life you will see the manager will give you data and will call you as a data scientist, derive some insights and present the report. Okay, so maybe in a tabular format, let's say some financial data has some rows and columns. Seeing those rows and columns, you cannot estimate anything, or you cannot understand anything. So as a data scientist, you will have the data, you will perform some operation on the data, and you get some insight, and you just need to report it back. You don't need to take any decision as a data scientist. So decision taking part is optional. This is optional. This is not necessarily there, but it can take a decision given a option. If the manager says depending on the insight, let's see in which area we need to work upon, like in which part of the state we need to open another another branch. Let's say SBI, you are a data scientist in SBI, you have got a report, your manager says just see this table, just run through this table, see in which state there is higher traffic a branch can handle, and depending on that insight, just give me a report of the states, okay, that these states needs this number of branches, new branches, because the traffic is very large. Okay, so that is a decision. Okay, now you are deriving a decision, and if the decision part is not there, you may say this is the data, these are the branches which have higher traffic, you should take a serious decision about it. Okay, so that depends on what kind of work you are doing to take the decision or not. Okay, so I guess this is clear what is the job of a data science. Now let's just roll over. Okay, now I will give you an example, and through that example hopefully you will understand what is the process and elements of data science. Okay, hopefully you can read here. So this is an this is an analogical example. So in this example, I have assumed that you have a day-to-day schedule, okay, to-do list, and that to-do list is provided by your voice assistant, Siri, Alexa, or Bixby is there. Bixby is provided by Samsung, if you don't know. If you are using a Samsung smartphone, maybe you have a Bixby assistant. Okay, you can use that. Okay, anyways, so let's say Siri, Alexa, Bixby is providing you a day-to-day task, a major task you need to perform every day. Okay, so I have taken 3 day, and 3 day they are very much different from each other. Okay, so at 7 o'clock morning, Siri wakes you up and gives you the total to-do list. Okay, so the first day I have taken as you are an expert, you need to provide, you need to deliver a talk on 6 p.m. at the evening on COVID-19 impact on digital education, right? So our digital education has transformed huge way because of this pandemic, and that is the reason primarily we are having this webinar. Otherwise we could have a physical one-to-one talk, but that is not possible. So that is a digital education progress in COVID-19, one positive thing to look up on COVID. Okay, so I have taken this example for that. So you have a expert talk to deliver on digital education, the evaluation on COVID-19. Day 2, I have taken that it is your birthday, so you need to throw a party. And third day is a day where you don't have anything specific to do, so you decided to do something productive. Okay, so you have 3 days. So what are the tasks you need to perform? What are the tasks in each day you will do generally? So I have designed those tasks, and we will see how this example can be related to data science. Okay, uh, if it sounds interesting, let's jump to the tasks. Okay, so day one, the expert day, you need to give a talk, right? So first you wake up in the morning, you fresh up, you do some exercise or yoga, then you have your breakfast. How many days, how many of you, by the way, do exercise? It is very much needed, you know. Anyways, uh, then after all those primary works, you do a research on the topic you want to deliver, right? Then after your research of certain hours, you make a PPT, then you are ready, and at 6 p.m. you dress up accordingly, formal outlook, and go to the occasion, right? You let's say white shirt, black pant, formal shoes, okay, uh, and you go to the party, go to the occasion to deliver your talk. Okay, then the next task is to go at the venue and deliver the talk. Fairly simple. And then once you are done with the talk, you come back home, you just reflect upon the talk of you just delivered, or take review and feedback, and improve upon the shortcomings on the talk you just delivered, right? So this would be a typical expert day. Okay, so let's have a look on the day 2, that is your birthday, right? The fun day. On the fun day, what we will do, it's your birthday, so you wake up, you fresh up, you do yoga, and have breakfast. These are all the primary tasks you do, whether your birthday or it is your working day, right? Then what you will do, you need to make the invitation list, you call up, you invite your friends, then you arrange the food, you arrange other things, maybe a DJ, okay, maybe some lighting arrangements or something like that, maybe the venue, maybe it is your home party, or maybe you want to go to some other places or restaurant perhaps to throw the party. Then you dress up according to the occasion, put up your best dress, okay, look smart and look happy, and go to the occasion. Then the next part is go to the party and have fun. Okay, that is the most fun part, right? And then after that, you wrap up the party and clean the mess, right? If it is your home party, obviously there will be some mess left out, and if it is your somewhere else in your restaurant, you do the pay the bills, right? So this is how your entire birthday works. These are the tasks. Okay, so just keep in the mind, although these are funny examples, and I made these interactive examples to draw your attention. Just keep mind these tasks, okay, or I will make you remember these tasks, T1 to T9, right? Okay. And on the next day, that is your no schedule day, what do? You do all those things, primary things, okay, then you pursue your hobby, explore nearby location, maybe perhaps read a book, do fishing, improve some of your skill, maybe that today is one of those days you wished and you thought of taking up this course or this workshop to brush up your Python or ML skills or AI skills, or you may do some work in hand you were thinking to do for a long time, okay, or maybe you check previous schedules and see if there is any scope of improvement, something you are doing or you have done, maybe there is something to improve on that thing. Okay, so these are the thing you do on entire day because you have nothing special to do or nothing specific to do, and then you reflect on the things at night when you are going to bed. You see what the things you have done, what are the results you have got after doing those things. So this is a no schedule day. So these are the three different examples I have taken, right? So what this example has to do with data science, right? So let's see the resemblance. Sorry, I guess I guess this is visible. So the resemblance here is the T1, T2, T3, T4. You see the wake up, the freshen up, the yoga and the breakfast part. Those are the part in terms of data science are called general or common tasks. Okay, no matter what product, what project or what system you are building, these tasks needed to be performed irrespective of the outcome. Okay, so what are these tasks? Data collection, data cleaning and pre-processing of data. So these are those wake up and do yoga and take breakfast. Those tasks are here. In data science we call it data collection, data cleaning and pre-processing. Okay, now you see the connection. Irrespective of whether it is your working day, whether it is your birthday or whether you have nothing to do, you need to do this thing. If you want to have a day or in other words, if you want to have a data science project, you need to do these things. So this is a general or common task. Then T5, T6. What were T5, T6? Let's have a look on T5 and T6. So T5 is pursue your hobby and explore new location on day 3. Day 2 it was invite you, make invitation list and invite your friends, arrange foods and other stuff. In day 1 it was research on the topic and make PPT. So you see these are some different tasks depending on what is the day, okay, and what is the task of the day, if I may say. Okay, so these are domain expertise for the data preparation. You need to know what work you are doing. You need to interpret the data that way. Okay, so if it is a biomedical project, if it is a biomedical application, you may do certain kind of operation. If it is let's say video surveillance, you may do certain other kind of operation. If it is image restoration, you may do other kind of operations. Let me give you the reference input of all these 3 examples. Let me image restoration. So image restoration, biomedical and video surveillance. Input of those things are image and or video. Okay, but depending on your application, you may need to perform certain specific domain task. Okay, so this is your T5 and T6. Now once you are done with those things, you do T7 and T8. Let me give you an idea of what is T7 and T8. If you may remember, what is T7? This, let me just skip this day 3. I will explain it again separately. T7, dress up according to the season, go to the party and have fun. T7 and T8. In day 1, dress up according to the occasion, go and deliver the talk. So it is just same thing. T7 is same, dress up according to the occasion, and day 2 also have dress up according to the occasion. But as the occasions are different, the dress up will be different, right? The occasions are different here, so the dress up will be different. And because the data the dress up will be different. The task, although feature engineering, you need to do feature engineering in every uh, data you have, right? But the feature engineering output will be different for different task. Okay, so the task is same, but the output depends on the application. So what kind of feature you need, what kind of operation you need, what kind of derived feature you want to have, that depends on the task. And model training, this is the most fun part, like giving the lecture or like going to the party and have fun. This is the model training. Here it comes all ML, DL, neural network, reinforcement learning. So all those algorithms comes here. This is the tiny part of it, model training, right? So if you have model training, but let me tell you one thing, this model training, it takes most amount of time to learn, and least amount of time to implement. When we will be doing this model training, you will see it is a matter of 3 to 4 line of code to apply, build a model and train a model. Okay, so this part, this up to this part, this part is the most troublesome, most hectic, most monotonous, whatever you say, task you need to do. And unfortunately this is the 70 to 80% of the task you need to do. Model training is like 5%, okay, and rest 10 to 15% of the task is your model deployment and maintenance. Okay, so what is now, you got the feature engineered, you got the model trained, then what is deployment and maintenance? It's just you have done everything with the data, you are done with the project, your outcome is giving you the result you wanted. Now it is time to give the model, make the model live. Okay, so there are various platforms like AWS, you must heard of, Google Cloud, Heroku. Oh, there are several platforms where you can deploy the model, or it can be your own server, your company's server, you want to deploy it there, or your client server. If you have a client, you are working for a client, you need to deploy it on your client server. And then when there is new data coming in, you want to train the model again, and you see what are the changes happening with the new data training, then you make some adjustment. These are the maintenance part. Okay, so this is the, these are the components of data science. I hope the components of data science are clear. So the takeout, okay, and there is a arrow here from feature engineering model training to data collection. So when you do the training, you check something. There is a cross check, right? You cross check. Obviously you have done certain amount of tasks. You need to see whether your output is the output you wanted at the very first place or not. If it is not the output, you will go back to the processes and try to minimize the error. What are the errors, and you need to do that. And let me tell you, it is not a one go process. You need to do many iterations in order to have a model that is deployable. Okay, and then also after deployment there are certain maintenance required. Okay, so data science is a iterative process, it is a continued process. Okay, Now the tools and processings you need. This is the part where the learning comes. So the language, preferred language are Python and R. Although Python is a slow language. The process in Python are slow, same as with R. Okay, if you call a fast programming language C++, okay, you can do it on Java also. You can do it in any language, any given language. You can perform data science. Then why Python and R are so like these two are hotcakes for data scientists? Every company want a candidate have a certain amount of expertise on R and Python. Why? Because there is very little or no learning curve. Okay, if you want to learn Python from today, you can learn it within 30 days. Okay, not everything about Python, because there are huge libraries, third-party libraries, Python things. Okay, but in 30 days you will have adequate idea to build a data science project on your own. Okay, or any project for that matter, right? So, and it is versatile, it is very easy to learn. So that is why these two are very preferred, and here we will use Python. For this workshop we will use Python. We will have some basic idea of Python and then we will move on. Then coming to the processing, what are the processing of data science? Data collection, data cleaning, feature engineering, data visualization, model design, model optimization, and deployment. Okay, and in this course what we will do, we will not do data cleaning, data collection. Okay, we will do data cleaning for a certain amount, data cleaning. We will do feature engineering, we will do visualization, we will design model. We won't be looking at optimization, and we won't be looking at deploy. Okay, so these 4 things we will be doing. Okay, so this is the course, this is the workshop about these 4: data cleaning, feature engineering, visualization, and model design. And what are the tools you need apart from Python? So many things. MySQL, MongoDB, I have listed a few of them. Apart from this also, there are so many things you can incorporate in a project. So what are these? These top three are the database systems. Okay, you need to have certain amount of knowledge about any SQL, structured query language. Okay, MySQL is a very safe place and easy place to start with. Okay, then these two are visualization tool. Okay, these are the visualization tool. These two are the framework that you need for deployment. Okay, and these are Docker, Kubernetes, AWS, Heroku. These are the platform. In different platform you need to follow different set of rules in order to deploy your project. Okay, so you need to know some amount of database system, you need to know some amount of visualization, you need to have certain idea of frameworks, and you need to know certain amount of knowledge about platforms, different platforms to deploy your project. So these are the tools, and certainly we won't be looking any of them in this course. We will only look at the primary tool, that is Python, and use Python for these 4 tasks. So this is the entire idea of this project or this webinar. Okay, so using the Python we will cover these 4 areas. And let me tell you, if you are quite good enough with this thing, you can make a project. Okay, you can make a project and show it off with your GitHub account. Okay, so with this knowledge, let me just switch to another part of this presentation, that is the data, the life cycle. Okay, so how these are connected, all those things we saw in last slide. So you may have a problem objective, or you may not have a problem objective, you may just have data, and the first purpose of your data science project is to find a problem. Find a problem. Okay, so your manager will give you a data and tell you, just look, anything is wrong in this data, whether anything is wrong in this data. So you, so this thing is your day 3. Remember the example we were talking, day 3, you don't have anything specific to do, you just go and find if there is anything to do at all, and do the thing and see if that thing serves the purpose. Okay, so problem objective, having a problem objective is nice to have, but if you don't have, you need to find the problem. Okay, that is the most cases, the majority of the days in a data scientist is to find the problem objective, then solve it. Okay, so let's say if you have a problem objective, then you collect the data, all the data you need to solve the problem, then you do data cleaning, then you do exploratory data. This is exploratory data analysis. Sorry, pardon me for my excellent handwriting, and because it is a digital pad, I am generally I am not this much excellent with my handwriting. Okay, so if you have any problem reading the data, reading it, just try to listen to me. Okay, and I will be on for the question answer round. So if there is any doubt, for last 15 minutes you can ask the problem, okay, or any slide you want to go back to, right? Okay, so this is exploratory data analysis. Let me just write one more time. Okay, much better. Then after the EDA, you go design the model and evaluate whether your model is working fine or not, and then you go to deployment. And let me give you the other arrows. With this model, after this step, you may have to go back to here, or here, depending on the evaluation. Okay, generally you don't go to deployment in the first go, you go repetitive process and then you go to deploy and see if the problem objective is served or not. So it is a closed circle loop. Okay, let me just erase it. So now with those introduction of data science, let me just yeah, much better. Let me just give you the idea of what is machine learning, the hot topic, right? The machine learning can be classified, as you can see, supervised, unsupervised, semi-supervised, reinforcement, and deep learning. Okay, so supervised is, so you have data and you have, let's say, labels. Okay, so data means you can have, let's say it's your marks, okay, the overall marks. Let's say if it is 90%, your graded level is P, okay, or let's say first division. If it is 60%, let's say second division. If it is 40%, let's say third division. If it is 25%, let's say fail. Okay, so this is a data. and there can be a many number of such occurrences of data. So this is called data. This is how data looks like. That is just an example. Okay, these are rows. Obviously you know this, because let me just tell, these are rows, these are columns. Okay, so we have rows. In rows we have certain amount of data and certain amount of labels. If we have labels, if only we have labels, that data is called, and we use those data and labels to make a machine learning model or train a machine learning model, then that model or that algorithm is called supervised algorithm or supervised learning. The process of learning of the algorithm is called supervised learning. Okay, forget about those further classifications of these. I will explain you in a bit. First, let me see what is unsupervised learning. Let's say the same data, just giving you the marks but not giving you whether you are passed or failed or first division or something, then this data is called unsupervised learning. The model that will learn from this data is called unsupervised learning. Semi-supervised learning is what? Semi-supervised learning, I have given you two sets of data. One set of data, there is nothing with the data, and some data is like 70 pass, 40 pass, 30 pass, 20 fail. Let's say this data has let's say 300 entries and this data has 20 entries. Okay, so the mix of these two data, using these two data, if I make the machine learning, this is called semi-supervised learning. Okay, reinforcement learning is something different. It is called reward based learning. What is reinforcement learning? If you do something, let's say this is the objective is, let's say a task, you are performing in a task. Let's say this is you, this is where you are standing, this is where you want to go. There is a river, okay, and you have three options. Okay, you may just jump, you may take the other way. Let's say there is another way which is going from the further way, and maybe there is another way that there is a pool, you can walk through the pool. Okay, so there are three options. You can take any of the options and accordingly you will be getting reward. If you take the option of jumping, you may fall in the river. Okay, so it is a negative reward. You may take the long way to go around the river, you may have a slightly positive reward, or if you take the pull, you may have the highest reward. So depending on your action, the model gives you reward. So here you is the agent, it is called agent. Okay, the agent performs certain task, and depending on the task, the model gives him reward. The output of the task is the reward. Okay, and depending on the rewards, the highest reward is taken as the optimized way to do the task. So once the agent learns the best way to cross the river, every time there is a river, it will look for a pool. Okay, so if there is a river, there must be a pool to cross the river. There is no other way around, or it may look the best option, the river. Okay, if it is not there, then it will again look for the other options and then see what is the best reward for those options, and it will follow that way. So that is called reinforcement learning. I hope that is clear by this example. And deep learning is nothing. Deep learning is not a separate type of learning, but it is like more of a black box. I prefer it to say black box. You give the data as input. A data can be labeled data. So labeled data means you have certain values and labels. it may be unlabeled data, it may have only values, and you give the data and do certain operation inside the black box, give some inputs or you may say parameter tuning to the black box, and in order to see what is the output. The output is the objective of your model. Okay, so that is deep learning. CNN is called convolutional neural network, RNN is called recurrent neural network. There are other types of deep learning also, and these are the different types of every learning. Okay, so we won't go details with each learning. In this course we will be looking only with supervised learning. Okay, so supervised learning, regression and classification. What is regression and classification? Let's see what is regression and classification. Let me see if I have. Okay, now if you have a continuous data, then the model that is suited for continuous data is called regression. If you have a discrete data, the suitable model for discrete data is called classification. Now what is continuous data, what is discrete data? The continuous data is like, if I say the model is to predict the amount of rainfall. If this is the objective of your model, to predict the amount of rainfall given certain data of the past rainfall of a area. Okay, the rainfall can have 5 mm, okay, 10, 20, 25, 27.6, 100, it can have any value. There is no definite outputs of this model objective. Okay, so in this case, if the output can have any value, that data is called continuous data, and for that data the type of model we use is called regression algorithm, or type of algorithm we use is called regression algorithm. On the other hand, if I have a set of data which is let's say I have a set of cat images and image of dogs. Okay, so now our model, if our model is to predict what of a new, if I give a new image, a model is supposed to predict whether it is a cat or dog. Okay, so I have trained the model with ample amount of cat images and dog images. Now when a new image I given as an input, the model supposed to give an output whether the image is cat or dog. So the output of the model can have only two values, on either cat or dog, right? Even if you give a image of a human, or a dinosaur, it will give an output whether it will say it is a cat or dog, either of them. Okay, no matter what image you give as an input. Okay, because the model only knows there are two things in the world for the model, that is cat or dog. So whatever you give, it gives output as cat or dog. So the output is definite and discrete. So if the output is definite and discrete, the model, the output thing, this algorithm, the output of such output is called classification. It is classifying the image as this or this, or maybe there are if I have let's say dog, cat and horse, image. So it may learn that there are three kind of things in the world: cat, dog and horse. Whether if you give a human or dinosaur or another, it will say it as a cat, dog or horse. So it can have a number of output, but the outputs will be definite. So we know beforehand what will be the output. Among those, one of them will be the output. Okay, so this kind of model is called classification. So I guess regression and classification is clear. It will be more clear when we will do coding. Okay, so theoretical part is very less. So today only we will be doing theoretical part, and if time permits we will jump into the modeling part of it. So let's just go other things, the terminologies of the machine learning. So we have known what is regression and classification. Now we will need to see what are the terminologies we used in models. Okay, so let me just, yeah. So there are two things called bias and variance. Okay, bias is the difference between the predicted values by the model and the correct value. Being high in bias giving a large error, blah 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 blah. And variance is called the variability of the model predictions for a given data point, which tells us the spread of our data, called variance of the model. Obviously this definitions are very much confusing. Let me just simplify it. Okay, so this is your model, right? Let me give you an reference. The model says for a given age, the height. Okay, let's say this is our age, this is our height. Okay, so 0.057, 10.5, 14, just don't take, because 14 14 is not a height, but just for example, let's say. Okay, so with increasing age the height increases, but after certain age, let's say this is a scale, let's say this is into 2, and the if I take any point here, let's say into 2, okay, into 2. So at the age of 2, 4, 8, 12, 16, 20, so after 20 maybe the age, the height remains constant, it doesn't increases, right? So the model, if I give you a model with age and height and the relation between them, and ask you to predict what if this is the height and age ratio of a father, what will be the age ratio, age and height of his son. Okay, or such kind of problem, or given a overall human height and age ratio, given that predict height of a given child, let's say the child having age of 15 years, what will be the age, right? So if I try to predict everything accurately, right, everything accurately like this here, so this model is trying to predict everything almost with a zero error. So whatever be the age with the height, it tries to put it in a loop, right? So this is a very simple example, and in this case, in this model, it says no, this is the thing, if I take a straight line, maybe I can predict the age and height. So in this case, if the height of this is 4, or 4 into 2, 8, so it will go here and it will say something around 6, so it is a 6 feet, Okay, so it's a in 8 years of age the height is 6 feet. Not practically it is possible, but let's take for example. But if you see the actual data point in 8 years of age, it says the height is around 8.5, right? So there is an error here. So this is called the induced bias. I know, but I just draw this line and consider this error. In this case, the other one, it says if the age is 8 into 2, if the age is 8, it will actually predict the exact value, right? It says it is 8.5. Okay, if the age is no, sorry, it is not predicting, it is just learning. Okay, here also it is learning. So if the age is 8, it learned the age will be 8.5. If the age is 12, it learned the height is 10.5. If the age is 16, it learns the height will be let's say 13. So it learned perfectly all the ages versus height. Now what happens when a new data is given here also and here also? What it will do? What it will do? Now once after the training, when a new data is coming, all it has is this line, and for this model it has this line. Okay, now when I am saying let's take another, not 15, let's take 5 years of age. Okay, now 5 years of age, it takes somewhere here and it tells, now for this model it says it is 7.2. for this model 5 years of age, oh sorry, it's a 7.3. okay, close enough. Now let's take something here, 3 years of age, right? So in 3 years of age, what it will say? It will say something like let's say 4. In 3 years of age, it will say something like 4.5. In 4 years of age, it will say something like, or it can go up to shoot up to this. In 3 years, sorry, let me just clearly draw it. Okay, so this is the line. Let's say for age 3 it gives 4, for age 3 it gives 4.2. okay, for 3.5 it gives here let's say 10. For 3.5 it gives 5, right? So for 3 years of age, the model, this is model A, this is model B. The model A gives 4, model B gives 4.5. For 3.2 years of age or 3.5 years of age, A gives 4.5, B gives 10, right? So model B is varying largely, and the variance is very large. Because of that, there may be a very diverse prediction way off the actual value. Okay, so and A is pretty consistent with the values, but it is actually very far off the actual value, right? It is very far off the actual value. So both model are giving certain amount of error, right? So this error is somewhat predictable, that this much of error will come, and this error is somewhat very unpredictable, or maybe sometimes it will give very accurate, sometimes it will give very large of number of error. So there is a trade-off that is called bias variance trade-off. Now the ideal case will be something like this, that we all know. If this is the model prediction, then it may give almost accurate or minimum amount of error. So the more variance gives more unpredictable or variety of results, the less variance or something stiff gives a constant amount of error. So we need to input some bias, some stiffness in the curves to have a considerable amount of error, given that with the model is persistent with its prediction. Okay, so this is bias variance, and this is the trade-off we need to have in order to have a considerable amount of model prediction accuracy. Overfitting and underfitting. The overfitting happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model. Okay, so if we go to the previous slide, let me just give you here an example. Okay, so let me just give you an idea. Now the bias and variance thing will also be clear. So my YOLO is called training data, okay, and my blue is called testing data, right? Now if my model is something like this, okay, then with weight and height, right? This is a weight and height. So with this model, if you see, the error is 0, almost equals to 0, right, with the training data. But now if this is the new data, that is testing data, if I want to predict the height of given, this is the weight, right? So the model, what it will give, because it has so minimum error, it will say that the previous thing I had with this height having with this weight had that height, so it must be this height. So this is the amount of error it have in the prediction. Now next, see here, so this is the weight of the actual, this is the actual height of the guy, and this is the weight, but the model will predict the height like this. So it will go up to its curve and it will see something up to here, okay, and it will say the height is this much. So here we also have this amount of error. So if the model is very much well trained with the data with 0 training error, maybe the model will fail miserably to predict the next unseen data, okay. So this is the amount of error every time it is inducing. This is the first error, this is the second error, and maybe the error will go up and up and up. So this case is called overfitting. This is overfitting, and this is high variance. The line is varying very much with the training data, and if I just lower the variance, what will happen? If this is not the case, this is not how the model curve looks like. Let's say the model curves look like this, okay. So let's see, this is the model. Then also here we have high variance or high error. Let's say here we have a little less error, here we have very less error. So if I reduce the variance, the error is less. Let's reduce some more. But remember, when we are reducing, let me just draw it for your reference. When we are reducing the variance, we are actually allowing some error in the training, right? Now let's see, uh, we are allowing this much of error at the time of training. We know the model will predict somewhere here, but we allowed it. We know something like this will happen. This much of error we are allowing. This is the bias. At the time of training, if we are allowing some amount of error, that is called the bias. Because of the bias, this unknown data will be predicted with a consistent amount of error, and the model is considered to be less erroneous or persistent. Okay, so this is a good model. It can predict any kind of data, right? Of course, otherwise it is an outlier. The output data is an outlier. Okay, so this is called the overfitting. That is called underfitting. Now overfitting, let's say we have only this much of data available, and if I train this model, the model may have a output characteristic like this. Now because this kind of data is unseen, if I say weight is this, the model will predict the height like somewhere here. It will say the height is very much way above, which is far from the reality. So because we have insufficient amount of data, or because we don't have the entire range of the data, the model is underfitted. Okay, we don't have enough training of the model to fit this kind of data into this model, right? So this is called underfitting. I hope underfitting and overfitting is clear. Okay, now let's see what is feature. Feature is nothing but, if given a data, certain amount of attributes of the data. Let's say for a human, let's say whether the human is fat or healthy or slim. So what we will have her age, gender, BMI, maybe height. So let's say we have these 4 kind of information about the human, and depending on that we may say he or she is healthy or slim or fat. So these variables, these are independent variables. These independent variables are called features, and that the dependent variable, depending on this information, we may call it fat or healthy or slim. This is called dependent variables. And this is called labels. Okay, so feature are the independent variables, and labels are the dependent variables. There is another thing is called derived variables. Derived variables, you may calculate the BMI depending on other variables, height, age, gender, weight, all those things. Okay, the BMI then is a derived variable, which is also considered as feature. Derived variable is feature, and that feature is a product of feature engineering. So we have feature engineering, that is, we derived certain features which is not primarily in the data, we derived using the present data, or we do some performance of the primary data to modify the data in our preferences, in our according to our need. That performance or that operations, those operations are called feature engineering. So it is the process of applying domain knowledge and statistical tool. So we need to have both domain knowledge and statistical tools to modify the data and derive some more data or more features from the given features and use it for model training. To enhance the model performance also, we do feature engineering. So this is the feature and feature engineering. Okay. So these are the handling missing value, handling outlier. These are some feature engineering techniques. Handling missing value, those I guess we will cover it in more details when we will be doing exploratory data analysis in the next part of our course. Okay, so just remember those terms: handling missing values, categorical, handling outliers. Okay, binning means grouping. Okay, so let's say, just for example, I have age as my feature. So I have age from 5 to 65. If I want to bin, let's say we will be binning, let's say 5 to 15, 15 to 30, 30 to 65. So these are called bins. This is my bin 1, this is my bin 2, this is my bin 3. So how we do that, we can see it. This is the output actually. Okay, this is the output. How we achieve that output, we will see in our next coding classes. Then something called one-hot encoding. Okay, those we will discuss when we, don't worry about these terms, or maybe some of you are familiar with this kind of terms. Okay, one-hot encoding is another thing. One-hot encoding is like, let me just give you an example. Our model only understand numeric data. Okay, so we may have some other data, like here for example they have taken color for our purpose of understanding. Let's say a data which have age, height, gender. Let's say this is our data, right? So age and height will have numerical values, let's say 20, 30, let's say 6 feet, 5.2. Let's say another one is having 25 years of age and the height is 5.5. Okay, and this is male, this is female, this is also male. Okay, so here these are called numerical features. This is my let me just write it here. These are called numerical features, and this is called categorical features. Categorical features. But computers or algorithms don't understand categorical features. To make them understand, we transform it to something numerical. So one-hot encoding is one of this transformation which we use to transform categorical features to numerical features. Like here we have male, female, 2 categories. Here we have 3 categories: red, yellow and green. So one-hot encoding is 1 and 0 0 for red. For yellow it is 0 1 0. For green it is 0 0 1. If we had another called black, the number of unique categories is equivalent to the number of columns or number of elements in the one-hot encoding. So we have here 3, so we have 3 elements and only one of them will be 1 and others will be 0 to represent one unique code. So for red here is the code 1 0 0. For yellow the code is 0 1 0. For green it may be 0 0 1. Okay, so this is one-hot encoding. There are other types of encoding also available. Okay, that is called level encoding. So there are red, yellow, green, we simply term it as 0, 1, 2. Okay, that is also possible, that is also feasible. Okay, let's see what we have others. Okay, feature split, splitting the feature. Now let's this example only, let me take this example. uh, in this case the data has a feature called name, right, and the name consists of first name and last name. So from name we can have two output, f first name and last name. So splitting this name will result like Luther Gonzalez may lead to two columns. So this is my data 1 which I have name as a feature. From that we can have another data 2 where we have first name and last name, right. So this is another feature. This is a derived feature using feature split operation which original data didn't have. So we have now in our data first name and last name. So this is a split operation. Okay, so how we do that? If you know a little bit of Python, you may see here we have split operation and we mapped it using lambda function. Okay, don't worry too much about it, we will be discussing about those things on later classes. Okay, so this is a type of operation we do. Scaling is another important operation. In scaling we scale a feature, a particular feature, into minimum and maximum value. Okay, so let's say if age is a feature in our case, so age can vary from 0 to theoretically infinite, right, and age can have any value. So or for example, let's say we have voltage. It is hard to imagine age as 1045, but we can imagine voltage, right. So it can have minus something to plus something. Okay, let's say minus 200 to plus 200, right, in our input case. So if we use the entire scale, it is going to take more memory, it is going to be more versatile, and it is more complex for model to learn. So in order to have a specific range, what we do, we transform it generally from 0 to 1 or from minus 1 to 1, or can be in any range, but it should be bounded. Okay, it should be bounded, that we know that is the minimum value, that it should have a minimum value and a maximum value. So this operation is called scaling. Generally we prefer 0 to 1 conversion. So how we will do that? Taking any element and that element subtracted the lowest element divided by the x max minus x. So it is just a statistical formula. You may already know that how normalization is done in statistics. If you don't know, this is the formula, fairly simple formula, right. So let's say we have let's say 1 to 10, and we want to normalize the element 5. So what will be our x is equals to 5, so x min is 1, x max is 10. So what we will do, 5 minus x min, sorry, so it will be 5 minus 1 upon max is 10 minus 1. So it will be 4 by 9. Okay, understood? So it will be always between 0 to 1. Whatever, any value from 1 to 10 will be always within 0 to 1. So this is a scaling. How we do it in Python? This is just the coding version of this formula, right? There is nothing, no syntax we have used. That is dot minimum value, maximum value. That is the value minus the minimum value up divided by maximum minus minimum. Okay. Don't worry if you have any question. I will give you time last 15 to 20 minutes so that you can ask a question, or I can also use the time to interact with you. Standardization is another way of scaling. It is just a statistical way of scaling. We use the min max value. Here we use the mean and standard deviation. Okay, in case of minimum and maximum value, we use standard deviation and mean of the entire data set to do the process, and that process is called standardization. Okay, so it is also a part of normalization process. Now comes the model validation and performance measures. So once you have a data, let's say you have 100 samples in a data set. Okay, so in that 100 samples, you should not use it entirely for training. Okay, if you use this for training, you don't have any new data left for testing the model, how good the model is performing. Okay, if you use the entire set and use it again for testing, the model will perfectly predict it, and you will get 100% or 1 probability always, which is not necessarily the case. Okay, so to do that, to evaluate our model, what we do, we split the data into, let's say 80-20 or may 70-30 or whatever ratio you think is fit for the model. So this is our training, this is our testing. Okay, so the training and testing is just the partition of the data, right? Now how we will decide which 80 samples we use for training, which 20 samples we use for testing. So to decide that, what we do is called cross validation. Actually it is called k-fold cross validation. Now why we do that? Let me just give you an example. Let me just say I have a system that has a data like this. This is a signal data, like let's say. Let's say this is our data. Okay. Now if I take 80% of the data, like say this is my 80% for training and this 20% for testing, the data, the test output will have very less accuracy, very less than, let's say 40% of accuracy maybe it may give, because the training samples are very much different from the testing samples, right? Similarly, if I take last 80% as training and first 20% for testing, So this is my test, this is my train. Then also the first training data is very different from the last 80%. So what should we do? We should take take, let's say 5, we fold it in 5 part, and we take 5 part means every part will have 20%. This is 20, this is 20, this is 20, like that. So at the time of training and testing, what we will do, we will keep every one part, let's say this one, for training, for testing, we keep that and train using that. So training with last 80% and testing with the first 20% or 20 samples. Then we use that in training, use this, kept this as testing, and use the left also for training. So this is the, and test the overall performance. So this is the 5-fold. So we folded the data in 5 times and kept for any every time we kept one part for testing, right, and evaluate the model output. So obviously the model will have different outputs for different training testing. So using that, using those performances, using those outputs, we will average it out. So this is an average 1/5 and summation of the all performance, I equals to 1 to 5. So the average performance will be the performance of the model. So this is called model validation technique, that is cross validation techniques. Another cross validation is called percentage wise. So this is my 100 samples, let's say, we call it test trend split of 80-20. So 80 data, 80 points will be picked up randomly from this 100 points, not necessarily sequentially, but random 80 points are taken as testing, training, and random 20, the other 20 is taken for testing. Okay, so the data are, because the data are random, so it may have less amount of bias towards certain amount of sequence. Okay, so it is also another possible validation process, but k-fold cross validation is more suitable for most of the cases, but however perhaps you can use that process also. Okay, so depends on your application again. So and the k means the number of folds. It is, if k equals to 5, then 5-fold cross validation. Okay, let's move on. Now the most important part is confusion matrix. So let's say, okay, the confusion matrix, obviously what we are the confusion matrix is part of evaluation, and evaluation of a classifier. Okay, so confusion matrix is applicable for a classification task. If it is a regression task, for regression we have something called mean square error. Okay, and other error measurement. Okay, we will talk about those also when we will go through linear regression. Okay, how to calculate mean square error and other error measurements. But for the time being, classification, for classification where we have distinct outputs, remember cat or dog. So those are the classes. If we have distinct classes, how the evaluation of the model is measured. So we have a matrix here. The matrix rows represents the actual classes, matrix columns represents the predicted classes. Okay, so the term here, the positive, negative and all those things, the terms here are, let's say cat and dog, okay, cat and dog. So the input was cat and the model predicted as cat, so both are positive, okay. So then the output is called true positive. If the actually it is dog, and the model predicted is as dog, it is called true negative. Or let's say not dog, let's to make it more going with the flow, negative means not cat and not cat. Okay, so the actual image, if the actual image is not a cat and the model also gives the output not a cat, so it is a true negative, right? Now what is this then? This one is false negative and false positive. Now if the actual input image is actually a cat but the model says it is not a cat, so true event, false prediction, right? Then it is called false negative. True event, false prediction, false negative. The event is false and the prediction is true. So the image which I given as an input is not a cat image, but the model says no, it is a cat. That means it is false positive. It is positive but it is false. So the model prediction, if you see this, most of the time most of us get confused with this term, what is true positive, what is false positive. So the model predictions comes under the first part. If the model says it's true, the term is true. If the model says false, the term is false, okay. And here in this column, if the model says it is false, then it is false, and if the model says it is true, then it is true, right? Understood? Negative, if it is say it is truly negative, then it is true. So the prediction part comes the first word of the true positive false negative thing, right? And the second part comes as the actual thing. Actually it is positive, actually it is a cat, actually it is not a cat, or actually it is not a cat, and actually it is a cat, okay. So I hope this true false, true positive false negative is clear. Now using this we calculate certain things. So this is these, don't worry about this, these are explained in later slides. Let's take a look at them. Sensitivity, right? It measures the positive examples labeled as positive. So the positive examples, okay, so this is another example, spam and not a spam in your email, okay. So the actual email is a spam, so that is a positive example, and it is labeled or predict as positive, so positive spam, okay. So how sensitive it is? So actual spam, how many actual spam we have? We have this, the entire row is actual spam, so the 45 and 20, this is the total number of actual spam. And what it predicted only 45 out of them as spam and 20 as a not a spam. So the 45 which is predicted true upon the actual true, 45 plus 20 is the sensitivity, or it is also known as recall, okay. Then specificity, it measures the negative examples labeled as negative, just the opposite. the negative example labeled as negative. So what is the negative example? Not a spam is negative here. So how many examples we have not a spam? 30 plus 5, 35. And how many is predicted as negative? 30. So 30 upon 35, 85% specific the model is. So specificity actually defines how many negative things is predicted as negative. Okay. Then again, what is precision? Precision is the ratio of correctly classified positive samples and total predicted positive samples. Okay. So here also, what is the total number of predicted samples? Positive prediction. By columns we will see. This many samples are predicted as positive samples, and how many samples actually positive? This is the 45 samples. So this is correctly classified, this is the total classified as positive. So correctly classified upon total. So it is a column wise operation. Precision is a column wise operation. Okay. Just remember, precision is column, specificity and sensitivity are row operations. Okay. So if you remember this, it will be very much clear for you. Okay. Again, accuracy. Accuracy is very straightforward. The total number of positive the number of positive upon total number of negative. So what are the positive classification? Whatever it is says as it is, like these are the positive prediction or true prediction, if I may say. These are the true prediction. The true prediction are 45 plus 30, and total predictions means this is the total prediction. So that is this much. So 75% accurate, whatever example model we are using. Okay. So here the operation accuracy is diagonal. Okay. So again, if we see here, recall, just remember it, it is going to help you big way. Recall is row wise, RR, you can remember it like that also. Specificity, this is also row wise. Then precision, this is column wise, and even I get confused most of the time. And accuracy, this is diagonal. Okay. So the calculation recall, you just get the total number of this. Calculation of specificity, you get the total number of this upon true, upon the denominator, numerator will always be the true events. Okay. So in recall, this is the true event, 45 upon row wise plus kar dena. For specificity, true event upon row wise plus kar dena. Precision, column wise, this is the true event upon column wise plus कर देना. Accuracy diagonal लेके सारे को plus कर देना है. Okay, I guess this is clear. This is one of the most important part of evaluation. Now once we are done with evaluation, I guess this is the end. Now we will start with basics of Python, how to perform all those operations. And as now I have reached the end of the session, let's just take up the chats. I guess Just go to pi paradox. Let me just see if there is any question. So I'm open to question. Give me any question if you have. So we have 10 minutes left. If anyone have any question, you can ask. Okay, bias and overfitting. So bias is what I can say. We are induced. We have some amount of error induced by ourselves. We know certain amount of uh, error, so that we can have more stable model. Like for this example, if we go back in our class here, where is the bias thing? Here, if you can see here, uh, if we have let's say these are the training examples. So if we want the model is to be very specific, no error, so what the model will try to achieve? The model try to map every value of the training input. Okay, so if you see, there is no output, no error after this kind of consideration of by the model. But so there is no bias. So here, in case this bias is 0. Okay, but this is the training example. What about other example, unseen examples? So if this is the new input, okay, as per the curve, the model, the new input has height this, but the model will not say the if the weight is this, the model will not say height this much. The model will map this weight to its curve and say this is the height, which is very much away from the actual height. Now instead of this much of less error in training, if we actually have more erroneous training, like say this is less varying. Okay, now I have same input training model inputs, right? But in at time of training, I have allowed this much of error. I know there is an error, but I allowed it. And what is the result? Now when the model have this, as testing, it may not say the exact height, but it will say this much of height, this is the height. It will say there is an error, I know, because of the error I have induced. Okay, so here I know this much of error I have induced, so I expect this much that much of error, so I can calculate the error and find more accurate height of that person. But because I have so accurate training, because I have, let's say, so accurate training, I don't have any error at the training. Okay, I don't have any error at the training, I haven't induced it. So if there is a error at the testing, I don't know how much error it is giving, right? I don't know, this is giving this much of height result, but the actual height is this. So this much of error, I don't know how much error I have. Only while evaluation I get a very poor accuracy like 20% or 30%, but I don't know how this error is coming, because my model was so good while training. It was predicting all the things, it was taken account all the things, I haven't induced any error. So that is called zero bias. So we induce some amount of bias in order to improve our model. So even if there is an error at the output, we know that because of the bias we have that output, and we can take account to that error and more accurately fine tune our model. Okay, so that is the bias. And because the model is performing so well at training but so poorly at testing, that situation is called overfitting. I guess now it is clear. Who asked that? Indranil. When will we go through the coding session? Okay, from tomorrow onwards there is entirely coding session. No more theory will be there. Could you go through quickly recall, scaling and so on? Mm. Recall, okay, Indranil, recall and other things. Okay, you mean the matrix, confusion matrix you want to, you are asking? Just let me go through, because you have mentioned two different things. Recall is from confusion matrix, scaling is from feature engineering. So let me know which one you actually mentioned. And Muhammad Kashif, which mathematics topics we need to require for data science? Suggest me any book or course for preparing mathematics topics for data science. Okay, Kashif, there are plenty of things you need to know in order to have a good grasp on data science. Let me just write it down. So, book, there is a book called Mastery in Machine Learning, I guess. Okay, that is a book. I don't remember the exact name. I will pass on the exact name and the author of it. Okay, this is a very good book. Then for courses, there are other, for statistics. For statistics, you may go to, let me just have a look if I have a book here to refer you. No, I don't have it in that time. No. Okay, I will suggest you some good books about it. And as far as the courses are concerned and other resources, the reason because I couldn't say you about the book, because I haven't learned it from book by myself, so I don't know, but I have some good references which I will pass on. The courses you may go through is for statistical, detailed statistics. Okay, there is a course on Coursera, like by Andrew Ng. Okay, there are a number of courses in Udemy, edX. Okay, and there are a number of good websites like Towards Data Science, Machine Learning, Mastery, Machine Learning Mastery, Mastery or something, Machine Learning Mastery. Yeah, that is the thing. Data Camp. Okay, uh, Geek for Geeks. Geek for Geek is for your coding and all. So there are number of resources you can go into, or uh, I would suggest you check what actually pi paradox is doing. They actually segregate all the resources available online, and with the experts they have, okay, they have designed few courses like master course in data science. Okay, and they have individual topics also, like regression, classification. Okay, uh, then they have I guess computer vision. Okay, natural language processing. So there are various courses which the main purpose of the data science is to decide which sector you want to have your interest in. Maybe you are into image and video, then you can go for like say computer vision. Okay, if you have a knack with audio and text, you can go for natural language processing. You can have time series. uh, if you have a knack for forecasting. So there are different application, and depending on each application there are n number of courses. No courses are bad courses, every course you learn something. Okay, but I would suggest you also check out the pi paradox courses, because they have curved for the learners that have very basic or few knowledge about data science and mathematics and statistics together. Okay, so the crux of each courses is built for the basic learner. So you go check those courses, and apart from that you can obviously go for these resources. I personally go to towards data science, machine learning mastery, and there is another geek for geeks. And the essential thing, the most essential thing for a coder or for a data science, that is your savior, is Stack Overflow. Okay, whether I say you or not, you will find it like a savior. Whenever you stuck on some problem, there is always an answer. And I uh, ask you and encourage you to go there, and if someday possible, you contribute, you become a contributor. Okay, contributor in Stack Overflow. Take up any question, don't necessarily very hard question, very simple question. Go through it, try to solve it. It will make your problem solving ability better. Okay, and some in maximum of the cases the code is provided. The one is asking with code, you go through the code, troubleshoot the code. That is going to make your code debugging skill better. Okay, so Stack Overflow is a very good place for data scientists, and another is Kaggle. Here the most of the things you can learn. Okay, like the data, how the data is represented, n number of people doing something on the same data. You can see their code, you can learn from their code. Okay, you can download the data. So open a Kaggle account, and you can even participate on paid competitions. Paid competition, if you can code and give a result that is good enough, you will have rank, and based on your rank you may get paid. Okay, top participants get paid. So that is far from now. If you are getting used to it, getting a very upper hand with data science projects, you may participate on competitions. But for a beginner perspective, You go, you check the data, you download the data, you see what others are doing with the data, and you try to replicate all those process and see how it comes out with you. Okay. uh, Scaling, specification, accuracy, such and such. Okay. What I'm saying is scaling, accuracy, specification. Okay. Okay. I will explain it another time. I mean, right now. So this is a confusion matrix. Okay. If the actual input is positive and your prediction is positive, good to go. If your actual input is negative and your prediction is negative, you are good to go. So these are the goody feeling, the happy feeling. Okay, true positive and true negative. If it is true, the first term of this confusing nomenclature, then that means your model is true. Okay, model is saying the truth. If it is false, then your model is telling a lie. So depending on whether your model is telling a lie or the model is telling a truth, depending on that, there are certain parameters. Okay, so what are those parameters? One is sensitivity. Recall means out of all the true things, how many true things the model is saying true, right? Out of 20 mangoes, how many mangoes are model saying these are mangoes, or how many spams the model is saying spam. Okay, that is the recall. Or you may say, I have shown you 100 spams, how many do you recall are the spams? So the model says, I recall 45 of them, what you shown are spams. Or you may say, I have shown you, let's say total, if I do total 100, like 45, 5, 50 and 50. Out of 100, I have shown you actually 50 spams. How many of you remember as spam? The model says 45, right? So out of 45 plus out of 45 plus 20, actually I have shown you 65 spams. How many of you sorry, let me just rephrase it more clearly. I have shown you 100 samples. Out of 100 samples, 65 were actually spam. Now I am asking you, how many you remember were actually spam? You said 45. Okay, so actually there were 65, you recalled it as 45. So what is your recall power? 45 by 65. Okay, so out of actual thing, how many you remember actual? Okay, you forgot 20, that is fine. So your recall power is 69. I guess recall is clear. Now let's move on to specificity, how specific you are. So I said out of 100, I remember, I know everything. Out of 100, I know I have shown you 35 things that are not mango or that are not spam. I know that. How many of you remember that those are not spam? So you say 30. So I know 35 were false things I have shown you, and you recall that 30 were false. So you focus on the negative side. Okay, now the first thing here, here in this case you are focusing on how many positive things you recalled. That is your sensitivity. Okay, and in this case specificity, you remember how many negative things you remember. That is the memory, that is called specificity. How specific you are, how specifically you remember this is not the thing. So out of 35, you remembered 30 non-negative things. So your specificity is higher, very higher. So I may say 100 good things to you and you will remember 50 good things out of that. but if I say 10 bad things about you, you will remember 9 out of that. Okay, so that is, so you are very specific, not sensitive. I guess I am making that specific and sensitive is clear. Now precision. Okay, now in case of precision, I ask you, I have shown you 45 plus 5, 50. Okay, I have shown you 50 samples on the first half and 50 samples of the second half. In first half, okay, in first half, how many were the actual samples? You say 45. Okay, out of 50, you are remembering 45 were the actual samples. So you are precise enough. Okay, and I said I have shown you where is this? I have shown you total 100 samples. I have shown you total 100 samples. How many of them are, I know that 50 of them are mangoes, 50 of them are not. Sorry, not 50-50, that is 45 plus 20, 65 of them are mangoes or spams here, and 35 are not. I know that, this is the data, this is me. And now I am asking you, out of 100, how many do you recall as mangoes, how many do you recall as not mangoes? You say, I remember 45 as mangoes and 30 as not mangoes. Okay, so you recalled this much out of the total, or you may recall this much correctly out of the total what I have shown. If you recall 65 and 35 correctly, then you are 100% accurate. But you recalled 45 and 30 correctly, so that is your accurate. That is how accurate you are. Out of total thing, how accurately you remember the right things. So I guess that is the accuracy. To put it in another perspective, if you remember the good thing well, you are sensitive. The true events, if you remember the true events, you are sensitive. If you remember the false event, you are specific. And the sensitive is also recall. Okay, and if you remember the overall event, what is your overall remembrance? This is the accuracy. And if I say, what is the total true things you remembered, total true, not how many true, what is the total you remembered as true, and what is the actually true, right? What total you remembered as true and what is actually true, that is called precision. Okay, so I guess now it is somewhat more clear, or this is still very much confusing? I want to do some small project too on data science. Yeah, we will be doing small projects. But first let me ask Indranil, is it clear? I guess now it is more clear to you. And then Mohammad Kasif, yes, we will do projects, we will do some little projects using different algorithms which you can use for your purpose, resume and GitHub profile. And in coming week we will be doing another workshop, hopefully, and there we will be doing big projects, some more deep projects like recommendation system, that you see in Facebook or Netflix. So a basic recommendation system, how to build it. Then we will be doing another natural language processing. So we will be discussing how natural language processing is done. So hopefully we will do uh, a more advanced project in the next week, but this week also we will be having coding sessions and projects using let's say linear regression, logistic regression. These are not small projects, but using basic algorithms. Okay, those you can also use as your portfolio projects. So yes, any other questions? Is it possible to go deep into AI without good base in data science? No, AI and data science are like synonyms. If you don't have data science, you cannot do AI. What is the where the intelligence will come from? The intelligence will come from the data, and how we will provide the intelligence from data using data science. So that is the process. Okay, and because you are giving the intelligence using data, that is why it is artificial. That is the first slide we discussed. If without data you can give intelligence, that is a natural intelligence which machine cannot have. Okay, so without data science you cannot have AI. Okay, anything else? I guess there is no more question. If there is no more question, I guess there is we also have crossed the time of 2 hours, so we can close it now, or if you have any question you can ask it now. Quick. Or if there is no question, please respond no question, so that I can uh, stop the live stream and see you in tomorrow's class. Tomorrow will be full of coding, no theoretical things, anything. We'll start right off coding. So all the theory and the boring stuff is over. Okay, so I guess this is it. Thank you for attending for so long time and listening to the theories firsthand. Although this is not the entire theory, there is so much to it, and if you join a full course, not necessarily in any course schedule, but if you join anywhere, uh, and I have liked the idea of pi paradox of one-to-one teaching. So if you join a teacher who can erase all of your doubts, it will be more beneficial rather than going for an online course where you cannot ask the instructor actually. So it will be beneficial for you. But however, you need to go through the theories, you need to know the background principles of algorithm, which we will be doing in coding from tomorrow onwards. So thank you and see you tomorrow. Okay, bye. Have a nice day.